Hello everyone, it's Fine and Steady, and today I'm going to tell you everything there is to know about Ethereum 2.0. But first, we have to start with what Ethereum 1.0 is. So that's the Ethereum that's running right now and the Ethereum we all know. So let's get right into it. So the first thing you have to know about Ethereum is that Ethereum is a decentralized network. Now, what's a network? A network is just a group of computers. Usually you would have these in one location, like Facebook has their data servers and their computers in one location. But a decentralized network means that these computers are spread out all over the place amongst many different owners and users, right? So every user who makes up part of the Ethereum network helps to decentralize it more. So what can you do? On this network, you can do things, and everything you do on the network is recorded in a list. Now, how do they manage this network? Well, to do things on the network, you have to pay a fee in Ether. This is what you would see then, like 1,700 US dollars per Ethereum is actually 1,700 US dollars per Ether. And every time an action gets recorded in the list, you get a reward in Ether. That's how it works right now. That's how it's still going to keep working. But now let's get into what Ethereum 2 is going to try to fix and what the problems are with Ethereum 1.0. Now, before we begin, I wanted to show you this super cute Ethereum Rhino. This is apparently their logo right now, and I just adore it. So let's go back to the top of the Ethereum.org website. Where better to get information about the upgrades? So what do you need to know about Ethereum 2.0 is that actually Ethereum, since its beginning a couple of years ago, had a roadmap of, look, we're going to start here. These are the changes we're going to need to make along the way. And once we've made the changes that we want to, it's going to be called Serenity, which they now renamed to Ethereum 2.0. So Ethereum 2.0 is just the culmination of all these changes that they want to make being done. So that's all you have to know. Ethereum 2.0 is just an upgrade roadmap to the existing Ethereum network. So what are some of the issues with the current Ethereum network? Well, they want to make it more scalable. Currently, it can do between, I think, 10 and 45 transactions per second, and they need to get that up to thousands of transactions per second, right? Visa, the card network, processes 1,700 transactions per second. So Ethereum wants to at least match them, right? But they're going to far exceed that. Second of all, they want to make it more secure than it currently is. And third of all, they want to make it more sustainable. Now, let me just show you how much energy this Ethereum network is using right now. Okay, guys, so here I have the energy consumption in kilowatt hours per transaction of a bunch of different currency stuff. So we have Ripple, we have Visa, we have MasterCard, Facebook Libra, Cash, Dash, Litecoin, Bitcoin Cash, Ethereum, and Bitcoin, right? So here we have Ethereum at 20.3, Bitcoin at a whopping almost 120, and Ripple all the way down here at 0.0000. Did I say that correctly? 4 zeros? Yes. 1133, right? As you can see, that's many orders of magnitude less. And that's kind of this range here is where Ethereum is targeting with their 2.0 upgrades, right? To give you an idea of how much energy Bitcoin is using, they use almost as much as the country of Ireland per year, and it would put them on the list of countries ranked by energy consumption at number 40. So Bitcoin has a huge power draw already, and Ethereum is not that far off. So huge energy consumption. This needs to be solved. Now, what else is wrong? Well, if we go back here, they're also having security issues. So if you own 51% of the computing power, right? So like it's a network made up of a bunch of computers and they're working together. And when they add something on this huge list of transactions, they get rewards for adding stuff there. And to do that, they use computing power. So if you own 51% of the computing power, you can actually make up transactions. And like we said before, currently they're only able to handle 10 to 45 transactions per second, and they want to get that into the thousands, which would match Visa. So how do they plan to solve these three issues? Well, it's actually pretty easy conceptually. Currently, Ethereum is based on a proof of work model, and they're going to change that to a proof of stake model. That's part one. So they want to go from a proof of work model to a proof of stake model. part 1, and part 2, they want to introduce sharding. Now those two upgrades, from proof of work to proof of stake and introducing sharding, are the two biggest components of this upgrade to Ethereum 2.0. Now let's go through what each of those are, and let's start with going from proof of work to proof of stake. So, as I said earlier, you are trying to add things onto the list of transactions, right? So you have transaction 1, 2, 3, 4, 5, and you want to get number 6, and you want to be the one to add it to the list, because then you are getting rewards. So everybody is simultaneously trying to figure out the 6th part of the list. Everybody working on this block number 6 at the same time, working on the same exact problem, causes a hugely unnecessary use of electricity, right? Because they could just say, hey, this guy, you work on it, and everybody else waits while he works on it, and you would only need to expend the energy once. Instead, you have like millions of miners working on it all at the same time, all wasting energy, because only one miner out of those million is going to get rewarded for it and is going to actually contribute to the block. So how does proof of work mining work? Well, you have a bunch of miners all working together at the same time to solve the next piece of the recorded list, all using energy to do that. Now, once the first person comes up with the solution and says, hey, I think this is the next block, then all the other miners look at it. They have a certain list of criteria, and if the block that this miner proposes, like let's say this is the one who figured it out first, he proposes a block, these guys all have a list of rules that they need to check, and if this block that he proposed matches all of the rules that they have, then they write it down in the register and they move on to the next block. That's proof of work. Now, I'm going to go over as well what the pros and cons are of proof of work in a second, but first we have to now understand how the proof of stake method works. So let's say these miners here got smart and they said, you know what? We're spending a lot of extra electricity that we really don't need to spend. What if we all just get together and we elect one guy to actually do the work of mining the coin instead of all of us doing it, right? So now there's only one guy using the electricity. And instead of us also doing it, we wait for him to come up with an answer, and then we just verify it, right? That's what we were doing before anyway, except now we skip the whole step of everybody simultaneously trying to come up with an answer to the solution. Now, one guy at random is elected and say, okay, here's what you need to know. You propose a block to us. We're going to check if we agree with it. If we agree with it, you're fine. You're good to go. But if we disagree with it and you're doing something bad, then we're going to take money away from you. Now, that's the difference between proof of work and proof of stake. First of all, in how the actual miners or the nodes are organizing and the actual method by which they're going about adding transactions to the list. Here, you only need to do the work once. Here, you need to do it as many times as there are miners. And second of all, how they're being rewarded. Here, if you do something bad, well, you just get called out and you don't get your rewards. And whoever solves it next correctly is going to get the rewards once everybody else agrees that he got a good answer. That's how you're rewarded in proof of work. And you're actually not punished for giving a wrong answer. You're not punished for it besides losing all of the electricity that you put in. Whereas in proof of stake, here, in order to get the system to work, everybody actually puts up their wallet, right? So they actually put their money on the line and they say, look, as long as this guy who gets elected does something well, we're going to reward him and give him more money. But if he acts badly and tries to do something negative to the chain and give us a false answer, we're going to actually take money away from him. So here you have an extra incentive to not be bad. Let's talk about the main difference between the two. So difference number one is energy consumption. Here, the committee elects one guy to actually do the work and process the transactions and come up with the next block, and then they verify it. Here, everybody is working together to come up with a solution, so there's a huge waste of energy until the moment that the first person says, hey, I have a block, then they switch and they're all validating it, and if they agree that that's the correct block, then they move on to the next one. But this initial phase where they're all working together at the same time to come up with one answer causes a huge waste of electricity. We're talking many orders of magnitude bigger than it costs to come up with the next block in a proof of stake. So if we go back to the things Ethereum is trying to fix with their Ethereum 2.0 upgrade is sustainability. That's how switching over to the proof of stake method improves their sustainability. Now, we can also talk about security, and security comes because of the differences in what's needed to break either system. So just so we're absolutely clear, in a proof of work concept where they use mining to come up with the next transaction on the list, you need to own 51% of the computational power of the network in order to force whatever block you want. So if you own more than half of the miners, you can force a fake list of transactions and say, hey, I just deposited like 1 million Bitcoin to myself. You could do that. Now, how much would it cost to actually own 51% of the computational power of the Bitcoin network? Well, if we go here and we ask Uncle Google, how much does a 51% attack of Bitcoin cost? One estimate puts it at about 15 billion US dollars. That's how much you would need to invest in computer network architecture in order to be able to successfully attack the Bitcoin network. So that's still a huge valuation, right? But the fact of the matter is, if, I don't know, a country or a big company decided that they wanted to do this, well, there are institutions, countries, even people who do have 15 billion US dollars. So an attack is very unlikely, would be very expensive, but it's possible, and the cost of that would be 15 billion US dollars. Now, in a proof of stake attack where what you have at stake is actually everybody's wallet at the same time, and you are elected based on the amount of money that you have, and as well, so you're elected first of all to propose the next block, but as well, you're elected to join the committee who's actually monitoring this guy who's proposing. You would need to own 51% of the money in the network. So if we go now to Ethereum's market cap, we arrive at 204 billion US dollars. So if you need half of this, you would need just over 100 billion US dollars in order to provide an attack on a proof of stake network. And additionally, not only that, it's not only the monetary cost, you actually have to go out and buy Ether. So that's assuming that you can buy half of the Ether that's available on the market, and that's also relatively unlikely. So instead of a $15 billion cost, you would need to have a $100 billion investment in order to attack this. That's way more money, and that's basically the biggest reason why this form of proof of stake is more secure. Editor's note here, guys, technically you only need to have half of the staked Ether out there, not half of the total market cap. But in theory, if both systems are equivalent, right, you're either using a proof of work system where you need half the computational power, or a proof of stake system where you need half of the value of everything that's staked. Well, the half value that's staked would usually almost always, especially in an equivalent scenario, end up being way more expensive. So that's the point I was trying to make. Now, you might be asking me, okay, but in a proof of work concept, let me go back to the diagrams. We have all these miners simultaneously. Let's say you have 1 million of these guys all simultaneously working on the same problem. So if one person gets it wrong or tries to propose something that's not correct, well, every additional miner is an extra level of security, right? And you would be correct in that the more miners you have, the more secure the network becomes. While in the proof of stake network, you only need an initial amount of members in the committee and here. So let's say you need a certain amount of people to actually be able to start a proof of stake network, and they've already reached that target. That was phase 0 of the Ethereum 2.0 upgrade. So let me show you exactly how the numbers work in a proof of stake system. In Ethereum 2.0, the proof of stake consensus mechanism will require validators to stake 32 Ethereum, which is now close to around $60,000, to run a validator node on the network, right? So in order to be able to be elected or to be on the committee, you need to stake approximately $60,000 in order to be eligible. And each time then that someone proposes a block, at least 4 and up to 64 random committees of 128 validators will be selected from the entire pool of validators to attest the block. This is if you have these numbers, right? So 4 times 128 or 64 times 128, you have a 1 in a trillion chance that an attacker controls enough validators to successfully execute an attack. Now, a 1 in a trillion chance is basically as close to 0 as you can possibly get when it comes to security. If you have a 1 in a trillion chance of this being corrupted or attacked, that is absolutely brilliant. And for this, you need, let me show you here, they will require at least 524,000 ETH, so Ether, to be in the system, divided amongst at least 16,000 validators. So while in Bitcoin, you can have up to millions of miners and whatever, here, the minimum that you need is 16,384. And if you add more validators, well, you're not necessarily increasing the security of the system, but what you can do is that you can run more transactions, because having more transactions running simultaneously does not decrease the security in the system, right? Going from 1 in a trillion to 1 in quadrillion is not like a huge change in the level of security. So how then, on this new system that Ethereum 2.0 would like to work on, are they going to divide their chain so that you can have multiple transactions running at the same time? Well, this brings us to our next point of sharding, and this is the point that is going to address the scalability. So let's get into it. Take a deep breath now. We're almost done. So we now know the minimum amount of validators and Ethereum that needs to be staked in order to have a secure network, right? But why don't we split the network and have many different simultaneous networks running at the same time, all connected to one main one that's making sure that all the subnetworks are staying correct? And that's what sharding is. Sharding is the splitting of one main network into many different ones. And initially, Ethereum would like to split itself into 64 shards, right? So if you throw down glass and it splinters into a bunch of glass shards, that's the same kind of concept here. So let me go down and show you exactly their roadmap of how they want to do this. So currently we have the mainnet. This is what you know right now. This is what's currently working on the proof of work concept. And this is how your Ether transactions are being monitored and fulfilled, right? If you say, hey, I want to send 10 Ether to my friend, then that's all working on the mainnet. If you want to run a smart contract, well, that's still currently working on the mainnet and going through this proof of work, very energy intensive, difficult to scale concept without sharding, without proof of stake. This is pure proof of work. Now, the first step, which they've already done to upgrading the system, is introducing the beacon chain. And what this is basically once they reached the minimum amount of validators and Ethereum staked that they needed to enable to have a secure proof of stake system, they would introduce the beacon chain, which currently will run in parallel with the main network, right? Because they don't want to just throw everything they want to run something, make sure it works, and then introduce it. So step one, which is going from the proof of work system of the mainnet and transitioning to the proof of stake system, is done on the Beacon chain. So remember, I talked about sharding and that they were going to split the mainnet into 64 different shards. Well, the Beacon chain would be, let's call it the first shard. Currently, they're not connected. So once you have the Beacon chain, which is basically the chain that is going to verify that every single shard is running correctly and that they're all, working together in tandem, you can start to introduce more shard chains. So shard chains will provide lots of extra data to help increase the amount of transactions mainnet can handle. They'll all be coordinated by the Beacon chain, but all transactions will still rely on mainnet, which will continue to exist as we know it today, secured by proof of work and miners. So this is where, in the beginning, when they first start introducing the shard chains, they're still testing everything, right? So on the shards, they're going to be doing specific things, like there will be a gaming shard where specifically applications that are doing with gaming will be running on the gaming shard, and there they won't be interfering with the mainnet shard. So you will be able to have, for example, one list of transactions related to gaming running, and as well one list of transactions related to money transfer running, and they will both be communicating to the main chain, which will be the Beacon chain, which is making sure Beacon chain, I kept saying Beacon chain, which is then making sure that both shards are working as intended. That's part one. And then the docking, which is expected to happen in 2022, is when the mainnet, which is currently working on a proof of work model, oh my god, I need to breathe here, is going to be transformed into another proof of stake shard added to the Beacon chain. And at this moment is when Ethereum 2.0 is complete. They will be able to process thousands and thousands and thousands of transactions per second, thanks to two changes. One, the transition from the extremely energy intensive proof of work model into the proof of stake model. So that's their first change. And their second change is, now that we have the proof of stake model and we don't need as many different nodes, validators, miners, in order to make sure our system is secure, we can introduce sharding, which means that we can have sub-networks all running simultaneously, and initially they want to have 64 of these. So guys, this is what the Ethereum 2.0 upgrade is. Sharding and the transition from proof of work into proof of stake. If you understood that, you understood almost everything you need to know to understand the transition to Ethereum 2.0. So guys, this episode was very difficult to research. I'm not gonna lie. There was a lot of moving parts here. I hope I was able to condense it as much as I possibly could without leaving any of the major points out, so that you guys could understand what's going on here. If I helped you out, if you learned something new today, please like and subscribe, and I'll catch you guys in the next one. Take care. I hope you got smarter. Bye-bye.